Welcome everyone to the webinar, and thanks for taking time out of your busy day. We're very happy and honored to present to you part 13 of our customer story series, Creating Knowledge Workers for the Greener Product Marketplace, where we bring you educators who have integrated lifecycle thinking and LCA into their curriculum. And today we are honored to have educators from graduate programs in innovation and business who are using LCA to teach their students how to generate new business concepts that produce environmental benefits as well. The underlying theme to this series is creating greener jobs. Is all about creating a greener economy. And schools will attract students to meet industry demand, and manufacturers will recruit those students from those schools who can execute. So it's this virtuous cycle of creating the knowledge, educating the workers, and bringing that knowledge into the marketplace. Sustainable Minds Eco-concept and LCA software has been in the market for the better part of 8 years, and in that time has been used in industry and in education, and we've been really interested to see the kind of adoption that we've had in education, not only around the world, but in every kind of curriculum, business, design, and engineering, in undergraduate, graduate, and even in postgraduate and executive training. Today, we're honored to have Steve Leonard from Carnegie Mellon and Josh Skov from the University of Oregon share with you their backgrounds, their experience, their work from the course that they're teaching, and their own insights into the value of integrating lifecycle thinking and LCA into curriculum and creating knowledge workers for the greener product marketplace. So in advance of Steve and Josh telling their stories, I'm going to give you a quick overview of the Sustainable Minds software so that you all have a good understanding of the capabilities. And so when Josh and Steve tell their stories, you have a good understanding of what they're talking about. So Sustainable Minds' mission as a company is to operationalize environmental performance into mainstream product development and manufacturing for the purpose of driving revenue and growth through greener product innovation. So again, the point is that our economy needs to grow, to continue, but we need to grow in a way that actually is sustainable and enduring. And so the incentive is to drive that growth through greener innovation. But to do that, it requires two parts. It requires that people learn to think differently, and then they learn how to measure. And when you do both, think differently and measure, you get truly greener products. So thinking differently is where the innovation happens, and the thinking differently is where we introduce Ecodesign, which is going to give students and professionals the framework for thinking differently and then being able to go measure. So we like to talk about environmental performance versus environmental impact, because in the world of products, we talk about functional performance, we talk about positive attributes of products, and so when you look at the criteria used today in product development, functional performance, cost, aesthetic, safety, environmental performance is just another one of those criteria. And manufacturers have already metrics and tools and frameworks that they use to evaluate those criteria to be able to make trade-off decisions about what products to make. But now that environmental performance is another trade-off decision, another criteria, having frameworks and tools to be able to get data, to be able to make trade-offs is critical. And 8 years ago when I was first giving this presentation, there might have been some eyebrow raising about the relative importance of adding environmental performance to this list of criteria, but I think today there's very little doubt left that there are external drivers, cost, regulation, supply chain risk, but also the real opportunities for creating new products, acquiring new customers, and new revenues, and building a credibly greener brand. Further, people used to think that green, with air quotes, would cost more, but the truth is that where there are environmental impacts, there are costs. And so when those impacts get diminished, so do those costs. So designing greener, more innovative products should drive down costs and increase revenues, and companies who really do make that a goal will achieve competitive advantage. And that said, it requires new knowledge, new processes, and new tools. So not only do manufacturers want to design greener products, they want to be able to market those products credibly as well. And brand is kind of the cornerstone of both of those activities. If they're designing a greener product, then they can tell credible stories to the marketplace, and that's what builds the brand. Now, if I haven't made the case strongly enough, the reason for evaluating the environmental impacts of products in early stage product development, which is what Sustainable Mind software is designed to do, is this, which is the decisions that lock in the specifications for that product when you get into detailed design are the same decisions that lock in the environmental performance. So selection of materials, recyclability, the amount of energy used, these are all the same decisions that affect environmental performance. So if the understanding of these selections is not made available in early stage design, once you get into detailed design, it's costly to make changes and often very difficult. So the big shift in moving to life cycle approach to product development is to adopt a whole life cycle understanding of the product, starting from raw material acquisition through material manufacture, product manufacture, transportation and distribution between all the phases, use, and end of life. And if that mindset is adopted in the very beginning of design, then we can start looking at how do we evaluate the impacts that are occurring in each of those life cycle stages, and then apply strategies that have been proven to improve the performance in each of those life cycle stages. How do we apply them to drive innovation and new ideas, or just even tactical improvements? And this is where thinking differently and measuring comes together. You can't just think differently and hope that improvements will be made, and you can't just measure and find out where the impacts are and not think differently about making improvements. The two go hand in hand. So life cycle assessment is really a process. It is a tool, but it's a process that is always looking for continuous opportunities for improvement. And this is the diagram that describes that. Like any study, you set up the scope and goal. What do you want to learn? You define the problem. Then you pull together all the inventory of everything that you're going to analyze that's going into the problem. You interpret the results. And then you make decisions about what to change to see whether you can make improvements, whether they're going to be meaningful or not. That's the interpretation part. And you can continue until you've decided that you're done. This is probably the most technical slide in the presentation. This is how we explain how we've merged the language of product design and engineering and manufacturing with life cycle assessment. So we developed this term called system bill of materials, looking at all of the inputs across the product system. And all of the inputs, which are also known as life cycle inventory data, can be reduced to its chemical composition. That's what the life cycle inventory data is the chemical composition of the inputs. And when those inputs get put through the lens of a methodology, all of those chemicals can be attributed to one or more categories of impact, and each of those impact categories can be attributed to one or more types of damage, either to human health or to the built or natural environment. So to make life cycle assessment simpler for product development teams to use in early stage design, we created a single figure score methodology that looks at all of the impacts created by the inputs into the product system and reduce it to a single figure score that looks at 10 categories of impact across the 3 damage categories to deliver a single figure score. Now we pull out the carbon equivalence because carbon footprinting is critical today to understand those impacts as well. And now there's really 2 types of decisions that can be made when looking to make trade-offs, either to improve the overall performance or to improve the carbon footprint. And the 2 are not necessarily the same. One can improve the overall performance and do nothing to improve the carbon footprint, or you can improve the carbon footprint and do nothing to improve the overall performance. And it goes back to what your goals are for the study and for the design process. Also in Sustainable Minds, the data is very fluid because methodology and data go hand in hand to build the models and deliver the results. We use data from EcoInvent and public data sources. When you have projects, either in industry or in education, that are specific to a problem you'd like to solve, and we don't necessarily have that data yet in our database, it can be added. And the way you can tell is you can go to the data browser, or you can go into a project and browse the data set and see if we have what you need. Typically, we will have it, or we can add it, or we can advise on a proxy to use. If you want actual data for that input, then we can work with you to add that as well. But what this is all in service of is ultimately to create models starting with a reference or a baseline, to then do an investigation of comparisons to see where improvements can be made and how significant the improvements can be. There is no such thing as a green product. All products use energy and create waste. So the idea of comparison is that something can only be greener than something else. And the Concepts tab in the software enables a user to easily build models and look at the amount of improvement and continue to explore as they drive through to a conclusion that gets them to the end of the study that they were trying to achieve. And I say it like that because the design is never done until you're out of time or you're out of budget. Otherwise, you could continue designing forever. So really, our software is eco-concept modeling with real-time LCA results. And if you just take a quick overview, the core of it is the comparisons tab, the results, which give you a whole variety of views to break down those comparisons, and then this pretty extensive learning center, which is the equivalent of about a 150-page textbook on Ecodesign and LCA. The tool is easy to use, easy to learn, for the purpose of benchmarking and comparing to get quantified estimates of environmental performance for non-experts, to have a standardized and credible system to learn how to integrate life cycle thinking into product development and be able to share those results and have meaningful discussions across disciplines, because there's lots of people who make decisions about products and companies today. And if we can get everybody on the same page, business design and engineering, thinking from a life cycle perspective, and all knowledgeable about how to measure, model, and compare, then we can more seamlessly create higher performing greener products and bring those to market. So with that, I'd like to turn the presentation over to Steve Leonard, who's going to talk about the course and his experience of teaching Sustainable Minds at Carnegie Mellon. Steve, take it away.
Thanks for the introduction, Terry. Good afternoon, everyone. My name is Stephen Leonard, and I will be talking about the vital link between sustainability and business and how Sustainable Minds helped my class understand and internalize this principle. My contact information is provided below should you have any questions after this webinar. So let's get started. Well, Terry pointed out the importance of doing comparisons on design, and that you can reiterate and iterate. There is no what I would call right or wrong. That's the slogan I use in my class. There is no right or wrong, only better. And I think Sustainable Minds helps us to get better. So, I am an adjunct professor in the Integrated Innovation Institute at Carnegie Mellon University, and I teach the Design for Environment class as well as the Design for Manufacture class, and have been doing so since the fall of 2016. I have over 30 years of experience of product design and product innovation, having worked in both consulting and corporate roles as an industrial designer, technology platform leader, and innovation leader. I currently work for Arconic, which is formerly Alcoa. Alcoa actually split into two entirely separate companies back in the fall of 2016. And I work as a senior innovation leader. Arconic is a world leader in the development of lightweight materials and product solutions for the aerospace, automotive, industrial, and building and construction markets. I received my Bachelor of Industrial Design from Syracuse University in 1985 and my Master's of Science in Product Development from Northwestern University in 2004. I did not mention it here, but I have over 50 U.S. patents covering a broad range of products from medical equipment and industrial type products to fast-moving consumer goods. So the classes I teach at the Integrated Innovation Institute are graduate master level classes. The degree received at the Institute is a Master's in Integrated Innovation. Interestingly, this curriculum is the pioneer in master's level teaching of innovation and product development, having been around for about 20-25 years. The Northwestern master degree I received from Northwestern was fashioned from CMU's Integrated Innovation degree program. And the books written by the director of the program, John Kagan, were required reading at Northwestern at that time. The Design for Environment class focuses on design and its impact on the environment. It covers topics such as the product life cycle, eco-design, sustainability engineering, and issues related to product development's impact on the environment. Emphasis is directed on the role of sustainability and on product development and how it affects design decisions. When I started to teach this class last year, I had approximately 42 students, and what I found out was that design for environment and sustainability was not a well-known topic among the students. Nearly 3/4 of the students had very little exposure to or knowledge of sustainability or design for environment principles. This bears out in the larger innovation ecosystem. Design for environment or design for sustainability, as it might be known, is not really widespread in many innovation programs within organizations and is seen as a nice to have, but not a need to have. Sometimes called a quaint notion if it can be worked out for the cost, so to speak. So the class was pretty diverse with a broad mix of disciplines from engineering like mechanical engineering, electrical engineering, automotive engineering, to name a few, to MBAs, architects, industrial designers and interior designers, and economics majors. In addition, the culture spread varied across the globe, which included students from China, India, Malaysia, Middle East, Europe, and North America. So it was a real broad range and a very diverse group of people. So within the Design for Environment class, I purposely structured it to take learning from the previous class, which was Design for Manufacturability and Assembly. The two classes were taught as 2 half semesters in length classes, and they were called minis. Each class is about 7 weeks in length, which is a tight period of time to teach the students the essential basics of design for environment. The course goals were to introduce concepts around eco-design, sustainability, and LCA, to show the beneficial link between DFMA, or Design for Manufacturability and Assembly, and Design for Environment mindsets, and to develop an understanding of the Sustainable Minds tool and the life cycle assessment using Design Project from the DFMA class. In this case, it was a toaster. I purposely picked the toaster in the DFM class, knowing that the Sustainable Minds tool had the toaster as a teaching case study in their software. So I made it a point to leverage the Sustainable Minds Learning Center tools and visual explanations of the life cycle and their link to DFM to sort of help sensitize the students to the importance of this link. What is common in industry today is a predominant focus on the front end of the life cycle, which is this red box, which really looks at raw materials, manufacture, and distribution. Very little is done to address use and end of life, and much of the design is based on cradle to grave. Therefore, many theories as to why this is happening can be it costs too much to be environmentally friendly, or sustainability is just a fad, to the more likely reason, which is a lack of knowledge or ignorance on the part of the people working in this area. So what needs to happen is an effort to educate industry in the value and impact of a holistic view of the product life cycle, from raw material extraction to end of life and disposal. In addition, to inform industry of the financial benefits of cradle-to-cradle ecosystems and the role that design for manufacture and design for environment, or design for disassembly, which is also an element of design for manufacture, can play along together. So those 3 elements can work very well together to help create that link with business. Several years back, I had the opportunity to use the Sustainable Minds tool for the first time on behalf of Alcoa, now Arconic. And the hypothesis we were attempting to validate was that lifecycle management and planning, in concert with design for manufacturability and assembly, would actually provide a financial benefit for product development. Design for disassembly was employed in a case study around a sofa product we purchased from IKEA. And we were able to demonstrate that design for disassembly and related design for sustainability approaches can actually benefit the financial bottom line. This can make a significant difference in the concept called the triple bottom line, which is a cornerstone for sustainability. The triple bottom line consists of 3 key elements: social or people factors, environment or planet factors, and economic or profit factors. Together, they create the environment to produce equitable, viable, and bearable solutions that make up the sustainable contributions. The diagram is one of many versions, and if you Google the triple bottom line, you'll find much more in that area. Currently, most of the focus today when it comes to DFE is centered around social and environmental factors and very little on economic. This puts a wedge between business and society. What needs to happen is prompting a complete picture of the triple bottom line that bridges that divide. In class, I stress the importance of linking design for environment and design for manufacturability and assembly, and how together they can create a win-win for all parties involved in the triple bottom line. Providing a clear link between these 2 design approaches can make design for environment more understandable to industry and enable product developers to develop or demonstrate the value of design for environment. The Sustainable Minds tool is structured along the lines of a product specification using the format of a bill of materials. In this case, it's called an SBOM, to help the user understand the environmental impacts of their design from a life cycle perspective. In the tool, the designer can make trade-offs and swap out different materials, material processes, or consolidate and modify the existing design altogether. This interplay improves product design much earlier in the process and lessens the cost of impact associated with the needless revisions later in development. Ultimately, the triple bottom line is really an interesting reflection of the design thinking process, which is the 3 bubbles on the right of the social, environmental, and economic. And the design thinking process is used in creating products that are desirable, viable and feasible. In the DFA class, we grouped the students into teams of 3. Each group would take their specific toaster project from the DFM class and reevaluate it for DFE using the Sustainable Minds tool. The assignment was to upload the bill of materials of the original toaster purchased on Amazon, and in this case it was from Procter Silex, and evaluate its environmental footprint. Next, they were to take the proposed redesigned toaster as part of their DFM class that they created and evaluate its environmental footprint and compare the relative environmental performance. Next, they would take their observations and learning and make adjustments to the materials selected and/or processes used on the proposed design to create an even better performing design environmentally. In some cases, the students actually redesigned the proposed toasters from scratch after seeing the environmental impacts. At the end of the term, the teams, or at the end of the project, the teams would provide a summary report capturing their findings and recommendations. Using the Sustainable Minds tool, the students were exposed to a variety of graphical interfaces and interface reports that Sustainable Minds can produce. By using the various display inputs, which is a toggle up in the upper left of the chart here that you can see, the students could look at, let's say, carbon impact, impacts by the bill of materials, or life cycle stage, just to name a few. This allowed them to see exactly where they make, where they can have a deficiency in the design, where their design would be performing well or not performing well, based on the impact score, which is captured in a normalized value, which is basically located here, total millipoints. It's a combination of different environmental impact factors. Approximately 13 different teams participated in the exercise, all with interesting but differing results. What was encouraging was that the students went above and beyond in their assignment and created 2, if not 3 design iterations over their current proposed design, which was a real pleasant surprise for me. The simplicity and the user-friendliness of the Sustainable Minds tool enabled the students to confidently make copies and revisions quickly to get options that are relatively accurate. What normally would take many, many hours to do so in a high-end LCA software, and the one I'm familiar with is Gabby Systems, only takes an hour or 2 for the first iteration in Sustainable Minds and less than an hour for the subsequent revisions. So you can go through many iterations and get a relatively accurate assessment of their performance. Some would say the drawback is the fidelity on Sustainable Minds is not as good as the Gabby system, but frankly, having worked with both, I don't really see that significant of a difference. So here you can see examples of moderate to significant improvements in the design. In some cases, you might have a reduction tenfold in this one toaster down here, or you could have only slight reductions over here, depending on how they approach the design. This is one specific example from a team. They were called Team Panggang 2.0, and Panggang is a Indonesian term used for a grilled meal in Indonesia. And the team decided to use that because they were going to grill their design on their what they would call their skinny toaster design. So they had their problem statement established, which was to minimize the environmental impact. And they proceeded to make, through the course of this exercise, an 83% improvement by virtue of adjusting different knobs on the software, whether it was the SBOM or the material or life cycle elements of the design. The results really supported their hypothesis of using low-impact materials, optimized design and manufacturing, and optimized end-of-life strategies. So the key learning really supported the value of looking at results from many lenses and be able to come up with a much improved design. So key learnings, the students came away learning about how the product is designed going in really affects the LCA coming out of and the ability to improve upon it. Secondly, material changes have a big impact on the LCA results. And even the kinds of materials within a specific class can have an impact. And lastly, principles of DFMA have a really big impact on the LCA results, which sort of ties and links the importance of the design front end with the impact on the end of life. Likewise, as an educator, I came away learning about how sustainable minds really help students see the impact of the LCA visually, and also help prepare students to be proactive in sustainable tools and approaches in product innovation. And lastly, help demonstrate the business value around sustainability when linked with other product development tools. So, Sustainable Minds really was an excellent tool for the students to learn on. It was very easy to use. And so from an academic lens, I'm starting to see a trend where tools like Sustainable Minds and other user-friendly tools are starting to grow rapidly in the academic settings. We used it as a new tool at Carnegie Mellon University in this class last year. And secondly, we recognize that there needs to be a broader outreach to engineering and business curriculum to really expand the tools beyond design and environmental science, or beyond design and innovation curriculums. And lastly, I think there needs to be continuous effort to demonstrate the value for product development via case studies as a mandatory thing that would really help promote the value of design for sustainability or design for environment, because it really does have a positive effect on the triple bottom line. From an industry lens, I feel that continuous education will be a key to success. I believe that the OEMs are starting to require an awareness of sustainability for designers and innovation leaders, and having an easy to use but relatively accurate tool like Sustainable Minds will help them out greatly. I think more communication and explanation on how it links with business will be important. And more emphasis, as I'd said, needs to be done in demonstrating the benefit to the triple bottom line to business leaders. What is the value that this will generate? That'll be crucial. I think that'll be very important. And lastly, T-shaped talent with broad understanding of sustainable tools coupled with business tools will be sought after skills in the future. Organizations are starting to recognize that there will be tremendous unreaped value in developing sustainable products utilizing tools such as this. So in conclusion, I believe that the Sustainable Minds tool was a really good tool for us to work on. And I'd really like to thank the Sustainable Minds organization about the importance of supporting us in developing this tool. And I cannot encourage folks more. Utilizing a tool like this could be very useful for your curriculum as well as very useful in your organization. So thank you very much for your time and attention, and I will wrap it up.
Thank you, Steve. That was a really, really great presentation, and we appreciate all the positive comments and kudos. We'll take those, and we're just really pleased to see you passing on the knowledge and helping those students move through that cycle. So we're just going to move right along, and we'll let Josh take over and tell you his story. In the meantime, if you have questions that you'd like the presenters to address or even discuss between ourselves, we will have time at the end, put those into the questions panel, and we'll definitely be working from those towards the end. So Josh, take it away.
Great. Thank you. Thank you, Terry, and thank you, Steve, for a great presentation. And also, of course, thanks to everyone on the webinar. I'm looking forward to some questions here. I'll introduce myself a little more in a moment. My name is Joshua Skov, and the title here, it's What's Inside That Counts, right? Is a little bit of a joke, but you'll sort of see what we're getting at there in an example that I'll share. I'm going to talk mainly about how I use Sustainable Minds in the classroom, but I'll also describe a somewhat unusual case study that might get the creative juices flowing for other instructors out there. So I will dive right in. So just quickly, a few notes on me. I am an instructor in the MBA program at the University of Oregon. I teach a few courses that have a few points of contact. I teach a life cycle assessment course I'll describe in detail in a moment, but also courses in clean energy finance and a broad introduction to sustainability in a business setting called industrial ecology. I spent about 15 years as a consultant. I still do some consulting, but I'm mainly at the U of O now on sustainability and climate issues for both business and government. And I've been very involved in, as a citizen here in Eugene. You see a typical Eugene scene there. That's me and my wife with our kids on bicycles. And the reason I put that in there is that I'm always thinking about the messaging on these issues to consumers and to citizens, because there's a really active municipal government here when it comes to sustainability and climate change. So a lot of overlap there with messaging in the business world. So briefly about the University of Oregon's Center for Sustainable Business Practices. That's really where I'm housed. That's in the business school. And we have the last 2 years been the #1 ranked green MBA program in the US. And I would just say there's a joke in there about weighting schemes and algorithms that relates to LCA. Whenever you look under the hood on those ranking systems, it's always a little messy, as LCA can be if you're not careful. So we can make that joke later, but I'm really required to brag, but I don't want anyone to think I take it too terribly seriously. I will say I teach mainly MBA students, but we have kind of a growing undergraduate program and a lot of interest there as well, and more course options. I just want to give you a quick sense of the LCA course that I teach that's primarily to business students. We get a few students from other parts of the university, but it's mainly first and second year MBA students. The overarching goal, as I put it, is to train savvy consumers of LCA with a connection to business strategy. And I stress the word consumers there because relatively few folks will go on to be full-time or even serious part-time producers of life cycle assessments. But there's an awful lot of LCA literature out there that has really valuable business insight. You certainly heard Steve talk about that in a variety of ways. And I want to make sure that my students, get a sense of what goes into those LCAs, and the best way to do it really is to have them go through the full process that I'll describe in a moment. My course is tilted a bit toward life cycle GHG analysis or carbon accounting, and I do spend some time on that. That's pretty common in the business world and maybe more common than LCA itself, but as I'll say at the end of the presentation, I think those things are tacking toward each other, and I'll describe that a bit. In my syllabus, I make pretty liberal use of the Sustainable Minds Learning Center, and I really encourage that as a tool. I include both elements of design focus and also the background information on individual impact categories. Terry mentioned earlier the Ecodesign strategy wheel. That's just one of a number of great annotated graphics and sections in the Sustainable Minds Learning Center. And so I've found that really convenient and powerful to have essentially a textbook wrapped around this LCA tool. Just to drive it home, I really recommend these materials. I think it makes for a really good student experience, and they're very high quality materials as well. So let me say a little bit about the team project of doing an LCA that's embedded in my LCA course. I have a lot of other readings, but this is a piece of the readings for the course, and then it's also a major part of the grade. It's a team project that students have. So the basic idea is to do a full LCA. And when I say a full LCA, I mean that it can be simplified in lots of ways. And of course it has to be, we're on the quarter system. We don't even have a whole semester to do this, but it's complete in the sense that it has clear, deliberate boundaries. There may be a bunch of exclusions that one might want to include if one had more time, but the point is that students are going through the full process of doing an LCA, drawing a deliberate boundary, and then including everything that they can. Typically, it's for an external client. We, this last quarter, had some garments from a couple of different clothing brands. And then we also looked at some packaging for a food consumer. That's not that's a common one as well. So pretty standard LCA applications, and so it's great experience for the students. The goals from my standpoint are, first of all, to give students that full understanding of and empathy for the full process of performing an LCA. And I say empathy because we often have technical results that float in front of us from some analysis. Maybe we read the whole report, maybe, more likely we read the executive summary and skimmed the rest. So I want students to walk through the process themselves and really understand what it takes to put together something like this. The result of that is that it reinforces those issues that should be front of mind for us, even when we're just LCA consumers, even when we're just reading these things. What were the boundaries? How is the study looking at multiple impacts? What kinds of comparisons are appropriate or helpful? And then a final goal is that occasionally we have student startups. That was the case this last quarter. That's been the case most times I've taught the class, that there's a student startup that wants to, straight out of the gates have really good environmental performance information, and being able to do an early, even simplified LCA of a product is really valuable for the reasons you heard earlier. And the example that you're going to hear today is from two great students I had who just graduated from the MBA program, Max Fleischer and Michelle La. And I will just briefly describe their process. And it's pretty simplified. Their report was long and detailed, but I'll give you a flavor of it. So the question here was really about the life cycle assessment of furniture and looking at an entire home. And you might think, why an entire home? Well, here were the big motivating questions that we had. What is the impact of furniture in an entire house? And can we get a sense of scale of this impact? And specifically, since we had some readings that focused on carbon footprinting in a similar setting, how big is that carbon footprint of furniture specifically relative to certain points of comparison, and what can we compare it to? So, big picture question about consumption, about the impacts, both greenhouse gases and other impacts associated with household level consumption. Now, the context for those big questions, and where you had some other readings, we had some other readings in the course, were, first of all, the students did individual carbon footprints, individual or household carbon footprints, either for themselves or their families, but to look at an individual household and go through the Cool Climate Calculator that UC Berkeley publishes. And we also looked at a very detailed multiple impact category LCA of a residential dwelling, a detached single-family dwelling. That's the long title I won't read there, but it was commissioned by Oregon's Department of Environmental Quality. So those big questions that you heard, what's the impact of furniture for an entire house, and how do we set it in context? Those questions had these contexts, these pieces of context for the students already. And the boundaries issues, which I think are often some of the most interesting things to look at in a course focused on LCA, were reasonable, but also begged interesting questions. So the calculator looks at the carbon footprint of an individual household for a year, but of course lots of consumption takes place across many years, often in a kind of lumpy fashion, buying a house, fixing a house, owning a house. And the same for consumer durables. And similarly, the LCA of the house really just focused on the house itself. It looked at energy use for the house and all the materials that went into the house, but not all the stuff inside. So reasonable boundaries for an LCA, but they still kind of leave you wondering about those other impacts, like furniture. So what do you do when you're interested in furniture? Well, of course, you go to IKEA, and in fact we did go to the IKEA website, and in fact I have to admit that part of my inspiration for this methodology was a recent IKEA purchase myself. And the reason I show you this is not to endorse IKEA. In fact, I should just say I'm not a paid representative of IKEA, and the use of product information does not constitute an endorsement of the company. But what's valuable about this is, what was valuable for us, and there's a lesson in here, is that ultimately the students, Max and Michelle, could assemble something like a bill of materials for all of the furniture in a house, and not just naming those things, but actually have a little bit of product information. So you see here for that Boeing armchair, one of the most iconic and common IKEA products, that in fact you have a little bit of information on the product composition there in the lower right. You see some references to materials, and then also, not on this screen, but if you order a product and you start to go through the process of shipping it, you don't actually have to order it to get this information. You start that process, put it in your shopping cart, you can see the weight of it. And so it was possible essentially to estimate all of the materials for all of these different products. So this might sound a little bit crazy, but I guess what I want people to take away from it is that often you have information that's out there in the public domain for one purpose, but it might have this great opportunity for student projects and for teaching and for analyses. So to summarize what the students ended up doing with the IKEA information, the details in the public domain provided this wide variety of typical furniture items. We had product materials and at least overall product weights from which it was possible to estimate individual components. In conjunction with Sustainable Minds, that means that we could put together an estimated bill of materials for every product and therefore for the entire household of furniture. And the student analysis consisted of kind of what you would expect: tables, chairs, beds, etc. You see the list there. We had to leave out a few things such as appliances, but we were able to get a huge amount of the furniture. And then the students did, and I won't have time to cover all of these, though there's delicious detail in their final deliverable, a reference case with variations by house size, because that went along with the LCA that we'd seen before, and also by furniture materials. As again, I won't describe in detail here, but there was a house filled with mainly wood furniture and a house filled with mainly aluminum furniture. So that allowed us to ask other interesting questions related to material selection. So the results, as you would expect in Sustainable Minds, looked a little bit like this. I'm just showing a couple of things here. These are really just prompts to point out a couple of things. First of all, there was a chance to look across impact categories for impact hotspots, and there was separate carbon footprinting information that I'll refer to in a moment. You see there in the upper right, the 340 kilograms of CO2. I'll talk about that in a second. But then also on the right-hand side, you see it by materials. So it's possible to think about hotspots through the lens of materials as well. So really great, easily accessible information to look at key issues in there. Now, I won't talk at the level of impact categories other than carbon and materials, but I do want to reference a couple of punchlines here. Looking just through the lens of greenhouse gas emissions, furniture is about 3.5% of life cycle GHG emissions for the house. If you include everything, like including energy use, which is the largest share by far. But if you look just at material flows, furniture actually makes up nearly a quarter of the carbon footprint. So about 340 kilograms per year for furniture and 1,400 kilograms of CO2e per year for all other materials. And the context there is thinking about the dwelling and the things you need for the dwelling over many, many years, right? It may not be exactly or anywhere near 340 or 1,400 in a given year, but over time, you need to buy and replace furniture. Over time, you need to repair a house, like re-roofing or re-siding. And so this kind of put these two material flows in that long-term context together. And the students were able to ask other interesting questions about both materials choice and durability questions. So in other words, small part of the total household carbon footprint, but a large part of materials. And the reason I think that's an interesting and appropriate way to frame it is that your strategies for dealing with energy use might kind of be off in one direction, things like decarbonizing our electric grid and having more energy efficient appliances and lighting, heating and cooling. But material flows are their own sets of issues to worry about. And obviously furniture is not trivial in those. And then also there were a whole range of views in their analysis into different material choices and how those resulted in different hotspots, different big impacts or big components being a large part of the impact, different types of materials. So I do want to point out a couple of key learnings. From the student standpoint, and I think this just reinforced a lot of other readings and concepts. This is definitely true across all the projects. There's always some point of contact between the student projects and their the rest of the readings in the course. And again, it gave that hands-on analytical experience of building an LCA from scratch, even if it's simplified. It is a real task, and I think an important one for the students to go through, to have that experience of setting up the boundaries, figuring out everything that needs to go in there, deciding on a functional unit, and then, of course, doing a full write-up for the project. From an educator standpoint, I say educators plural, but these are really just my insights, but I hope you'll get to have these same experiences using Sustainable Minds yourself. It's a great opportunity to get the students to be creative with course material. In general, it's a unilateral experience, instructors assigning material to students, but this is a great chance for them to wrestle at the project level with a reference concept and then these different variations. And then also really easy, just seamless combination of course content through the Sustainable Minds Learning Center and the project software, but then also that as part of the course worked really well. And this is just a great team project setting. If you have courses where you really want to cultivate teamwork, and that's part of what you do, certainly that's part of, I think, just about every MBA program, ours included. This is a great experience in that way too. So I wanted to make another quick comment on context and then wrap up with a comment on trends in the corporate world related to this. You heard me use the word context and the word comparison a handful of times. I just wanted to cite this piece from earlier this year. This didn't make it into my syllabus because this, I think, came out toward the tail end of my spring course. But this piece by Wines and Nicholas in Environmental Research Letters looks at personal choices, personal or household choices and their greenhouse gas emissions impact, and tries to set them next to each other in that bigger, broader context of consumption. And that's really what Max and Michelle were doing with the furniture study. They're saying, hey, this is interesting, but if you get a number as a punchline, that number doesn't necessarily have any context by itself. And so they were able to weave other pieces of the course, other materials from the course, into their final report and give it a bunch of context, which is really, I think, the kind of the holy grail when you're getting people to produce technical analysis. How do you get them to provide that context so the results have more meaning? And finally, just a note on trends. Carbon accounting and corporate sustainability, I think, are tacking toward LCA in some interesting ways. No full discussion here, but I just want to call out a couple of points. Greenhouse gas accounting boundaries used to be pretty thin and pretty narrow, right? We used to look just at direct emissions or emissions associated with electricity. And over time, as companies have woken up to the importance of looking at their supply chains through the lens of LCA, really, or look at their supply chains, even when just looking at greenhouse gases, looking at all of those different life cycle phases, carbon accounting and LCA really have, I think, become much more closely related. And so from a pedagogical standpoint, I find it really easy and natural to bundle these things in the same course, and also very helpful for the students. Also, I've worked with a number of companies in my role as a consultant previously and currently, but also my students in their internships. Often companies, start a sustainability effort thinking they should do a carbon footprint, and that's fine, but it often pretty naturally moves on to other impacts. And in that sense, LCA is a really good training ground for the students to have that experience of of looking at multiple impacts and greenhouse gases simultaneously in the same analysis and be able to talk about both of them. And this harkens back to what Terry said about the trade-offs earlier, but Sustainable Minds really cues that up by having those pieces tightly integrated. And I will leave it there and say thank you and hope to get a few questions.
Well, thank you, Josh. And I think Josh is really hoping you'll call him.
Yeah.
He is truly a wealth of knowledge and lots of stories to tell. And we'll just have to have you both back because, in spirit of full disclosure, Steve's been using Sustainable Minds since we launched the product, both in industry and now in education. And Josh has been teaching with it for a while, so a lot of great experiences. But I want to bring it back to how both of them have beautifully illustrated that creating knowledge workers for the greener product marketplace is not only crucial right now, it's a great thing for schools to do. And especially if you think about, a school is a business, and schools are trying to attract the best students and more students. And if they're producing students who can come out of school with marketable skills, then they're going to get the reputation for making those kinds of students who people want to employ. Sustainable Minds, using Sustainable Minds and knowing LCA is a referenceable skill that can be put on a resume. And we've heard many times about people actually getting hired because that skill was on their resume and they could speak to the use of LCA in making trade-off decisions. So as Josh just also pointed out at the end, that work today is very rarely done solo. Kind of gone are the days where there was a worker, a decision maker, maybe to the chagrin of many people that collaboration kind of slows things down. But if you have some tools that support the collaborative process that get people to better decisions more quickly, it means that collaboration is more successful, and individuals who are accustomed to working that way become better collaborators. And so, for the purpose of wrapping up this webinar, I just want to point out that we have free trial accounts. The trial software is the full product. It's not limited or a partial version. And we have made it very equitable to use in education. It is industrial software. The annual subscription for business is $1,400 a year. You can see that the educator subscription is substantially less than that at $350 a year, and student subscriptions are $49 a semester. And the more students you purchase for, whether it's for the class or multiple classes or departments or even school-wide, the quantity discount program makes it even more possible to purchase more broadly. When you leave the webinar today, there will be an exit interview or an exit survey, just a couple of questions to give us your feedback, but also one of them is to let us know if you would like the PDF of this deck, which we will happily send you if you let us know you want it. And you can go to our website and look at all of the webinars that we've had in this series. You can listen to the recordings as well as read a summary. They're all in our blog as well as on YouTube. And that really brings us to the end of our time. Looks like the questions that came in got covered. And I'd like to thank Steve and Joshua once again for sharing your experiences with us. And I'm going to wrap up on time, and everyone have a great day. Thanks, Josh and Steve.
Thank you.
Thanks.